Bismillahirrahmanirrahim. Today we are going to speak about the chain rule. Last time we spoke about the product rule, quotient rule, and power rules, and also sum or the derivative of sum or difference between two functions. We gave several examples, and for today we are going to speak about a new rule, which is the chain rule. The chain rule says that the chain rule that if g is differentiable at point x or in general at x, and f is differentiable at g of x, then the composition f composite g is differentiable at x. At x. Moreover, f, we say that if y equal to f of dx and u equal to g of x, then y will be written as y equal to f of u, and dy by dx equal to dy by du multiplied by du by dx, because this is the chain rule. So the chain rule is speaking about the composition of two functions. We are speaking about a function inside another function, or composite with another function, or maybe we can say it in general as nested functions. So f composite g, the derivative of f composite g, or derivative of f of g of x, equal to df by dg, or d in this form it is dy by dx, which is equal to dy by du, taking the first derivative or the first variable, and that variable also is a function of x. If you just look carefully about the form, I have dy by dx. If it is written in this form, there is no clear x. So it is just u is a function or implicit function of x. So it is y equal to f of u, then dy by dx equal to dy by du multiplied by du by dx. To make this one rule clear, we can think about the composition of two functions like we have two boxes. The outer box is f. Inside that one is g, and inside g we have x. So the chain rule, the derivative of this one, d f by dx is equal to, or y equal to df by dx multiplied by, let's make it in general, df by du and du by dx. The idea for the chain rule that we need to reach the x inside the second function. The derivative, it is like we are opening the boxes. So if I want to find d by dx of this box, first step, I'm going to open the first box. This is f prime. Inside that box, I have still another box, which is g. G is still not opened. So the first step, we open the outer box, which is f, that is f prime. What is inside is still closed. It is f prime g of x. Now, to get x, the next step, I need to open the second box. That is g prime. And then I can get x. I can get x from the second box. So the chain rule d by dx of f of g of x, like open two boxes. The outer box is the f prime, then open the interior one, which is d prime of x. So the chain rule is just find the derivative of the outer function, then multiply by the derivative of what is inside. Again, just to make it close to the understanding that we will think that the two functions are two boxes. The one box is inside another one, and to get the variable x, I will open the outer one, which is f prime. Then I will open the second box, which is g prime, the derivative of the second function. So this can come from the word chain. We are opening one after another one. The first function, then derivative of the second one. So it is like a chain of the process. To make this clear, let's take some examples. Let's find the derivative of the following function. Number one, f of x is equal to 4x squared minus 3x plus 5 to the power 5. And I need to find the derivative of this function. We have two ways to find the derivative of this function. Either I will open the brackets, I have 3 terms all to the power 5, and this will be time consuming. Not easy to open this bracket. Or we can apply the chain rule. For the chain rule, I have to know how many functions I have, so that will give me the number of derivatives I need to find. So in this example, see how many functions we have. Number of functions. The first function, or the outer box, it is the power 5. This is one function. The power, bracket the power 5, it is one function. The second function is what is inside. It is 4x squared minus 3x plus 5. So in this example, I have two functions, the power and the polynomial inside the power. Keep this in mind. I have two functions, means if we apply the chain rule, I will have two derivatives. Now the derivative of the, let's find out the derivative here. The derivative of the power by the power rule, it is 5 multiplied by bracket to power 4. As you know, it is minus 1. It is 5 multiplied by the bracket to power 4. This will be the first derivative. 5 multiplied by the bracket to power 4. Now the second one, the derivative of the polynomial is equal to 8x minus 3. So these are the derivatives. By the chain rule, we have to multiply the two derivatives. So the derivative of this function will be f prime is equal to these two, product of these two. It is 5 multiplied by something to power 4 multiplied by the derivative of the second function, which is 8x minus 3. So I have 5 multiplied bracket to power 4 multiplied by 8x minus 3. Now what should we write inside the bracket? It is the second function, as we said in the boxes. If we open the first box, still we have the second box closed inside. We didn't open it yet. So I have to keep it there inside the first box. After we open the first one, the first function, the second function should remain as it is, no change. So we open the first box, we will see the second box inside closed, which means I didn't take the derivative yet. So it is 5 multiplied by 4x squared minus 3x plus 5 all to the power 4. Then in the next step, we open the second box or we take the derivative of the second function, which is 8x minus 3. This is the idea of the chain rule. Let me take another example. Number 2. F of x equal to square root of x squared minus 3. And I need to find the derivative of this one. Also, I need to check how many functions I have. This one can be written as square root is 1/2. So it is x squared minus 3 to power 1/2, which means I have two functions, the power 1/2 and x squared minus 3. These are the two functions I have. It is composition of these two functions, square root and x squared minus 3. Now to find the derivative, the derivative of the square root is 1 over 2 square root. It is 1 over 2 square root. The derivative of x squared minus 3 is 2x. So the derivative now in this case, f prime of x is equal to, the derivative of the square root is 1 over 2 square root multiplied by the derivative of the second function, which is 2x, will be 2x. It is 2x. Now what should we write inside the square root? It is the original function. The first box or the second box is still closed. We didn't open it yet. We didn't find the derivative. In the first step, we didn't find the derivative of what is inside the function. So I have to keep it as it is. It is x squared. I have to be careful about this one. This should be remain as it is, x squared minus 3. Just to simplify it, I will have f prime of x is equal to, this 2 will cancel with 2. It is x divided by square root of x squared minus 3. So this is the derivative using the chain rule. we are differentiating the outer function, then we differentiate what is inside that function. One more. Number 3. Let's find the derivative of this one. F of x is equal to 2 divided by 2x to the power 3 plus 4x minus 1 or to the power 6. This is the rational function. I can apply the quotient rule here. Or I will write it as just function to power or to power negative 6. This will be or can be written as 2 multiplied by 2x to the power 3 plus 4x minus 1 to the power minus 6. Now see how many functions I have? We have the power minus 6, this is the first function, and we have 2x to the power 3 plus 4x minus 1. So I have two functions. It is two functions. Composition of two functions. Now let's find the derivative. This will give me minus 6 multiplied by bracket to the power minus 7. Just minus 1 there. Minus 6 with minus 1 will give me minus 7. The derivative of the 2x to the power 3 is 6x to the power 2 plus 4. So the derivative of this function will be the product of the derivatives. So f prime x is equal to 2, so the coefficient we have, multiplied by. The first derivative is minus 6 to the power or multiplied by bracket to the power minus 7. Multiplied by the second derivative 6x plus 4. So it can be written as minus 12 minus 7 multiplied by 6x plus 4. What is inside that bracket? It is the original function, which is 2x to the power 3 plus 4x minus 1. So this is the derivative of the given function. So again, we are thinking about the functions are like boxes, and inside these boxes we have x, we need to get to that x. So to get to that x, we have to open the outer box. We will find another box inside. Open that box, we will find x. In some cases, I might have more than 3 boxes or more than 3 functions. Number 4. Let's think about trigonometric function. F of x equal to sine of 1 over x. F of x equal to sine of 1 over x. Let's see how many functions I have. We know the derivative of sine x, which is that will be cosine x. Now for this function, I have two. One is sine and 1 over x. Sine and 1 over x. Now the derivative of sine is cosine. Derivative of 1 over x, we found it before, it is 1 over x squared. So the derivative of f of x now is equal to sine is cosine of the angle, we have to keep the angle, multiplied by the derivative of what is inside the bracket, derivative of the angle, which is minus 1 over x squared. The multiplication of these two. So sine gave me cosine, and 1 over x gave me minus 1 over x squared. Now what should we write inside the bracket? It is the angle as it is, no change. It is cosine of 1 over x. Then we differentiate that angle, which is minus 1 over x squared. So the derivative is cosine 1 over x multiplied by minus 1 over x squared. Number 5. Think about this one. F of x equal to 4 cosine square of square root of x. See how many functions we have in this problem, or in other words, how many boxes I have. You will see that we have the power 2, because this can be written as 4. It can be written as 4 cosine of square root of x square. Cosine square, it is like bracket all to power 2. So the first function is the bracket to power 2. Second function, it is cosine. Third one is square root. So I have 3 functions. I have x at the end. With that, x will give me 1 when we differentiate, so no need to write it. I have 3 functions, mainly 3 functions with at the end, which is x variable. Now the derivative of the bracket is 2 to power 1. Derivative of cosine is minus sine. Derivative of the square root is 1 over 2 square root. Derivative of x is equal to 1, and that's why we don't need to write it. So I have 3 derivatives now. I have 2 multiplied by bracket to power 1, then differentiate the second one, cosine will give me minus sine, then differentiate the third function, which is square root, that will give me 1 over 2 square root. So I have 3 derivatives now. F prime of x is equal to 4 multiplied by, the first derivative was 2 multiplied by 2 power 1, something inside. Then the derivative of what is inside, it was cosine. Derivative of cosine is minus sine of something also, multiplied by third derivative is 1 over 2 square root. Now let's fill the blank. What should we write in the first bracket? It is the function. It is as it is, because we did only with the power. The function inside, I didn't touch it yet in the first step. So I have cosine square root of x. In the second step, we found the derivative of cosine that will give me minus sine, but the angle is still there, so I have to keep it. It is square root of x. In the third step, we differentiate the square root, which is 1 over 2, and what is inside will be kept there inside. So the derivative is equal to, this is equal to minus 8 cosine to power 1 of square root of x multiplied by sine square root of x multiplied by 1 over 2 square root of x. Or just to simplify it more, I can cancel 2 with minus 8. So the derivative is equal to minus 4 over square root of x multiplied by cosine square root of x multiplied by sine square root of x. So this is the derivative of this function, where we have 3 functions. It is composition of three functions, which means that I must have four derivatives. I'm sorry, three derivatives. We must have three derivatives. Take one more. Number 6. F of x equal to square root of sine to power 3 of 2x minus 1. Let me see how many functions we have in this one. We have square root. We have power 3. We have sine, and we have 2x minus 1. So I have four functions, which means I must have four derivatives. The first one, square root, will give me 1 over 2 square root. The power is 3 multiplied by 2 power 2. Okay, 2 power 2. Sine will give me cosine. And 2x minus 1, when we differentiate, I will get 2. So the general form of the derivative will be a product of these four derivatives. So the derivative now will be written as is equal to 1 over 2 square root. This is the derivative of the first one, the square root. Second one is 3. This is my second function. So it is multiplied by 3 multiplied by something to power 2. Then third one is sine. This is my third function. The derivative of sine is equal to cosine. Let me take this out. Cosine of something multiplied by derivative of the fourth function. This is number 4. That will be multiplied by 2. So this is the general form of the derivative. Now let's fill the blanks now. Inside square root, we must have sine to power 3 of 2x minus 1. Because what we did, we opened only the first box. So the second function will remain there inside. We didn't touch it yet. In the second step, we differentiate the second function, which is 3 to power 2. Inside that one will be sine of 2x minus 1. Minus 1 and all to power 2. So the second function is power 3. Then we differentiate what is inside the bar, that is sine function. The derivative of sine is cosine, and we have to keep the angle as it is, which is 2x minus 1. And the last one, the derivative of 2x minus 1 is 2. So it is like we are differentiate the square root, then what is inside the power, then what is inside the power, then what is inside the angle. This is the chain rule. I can cancel this 2 with this 2. I will have f prime of x equal to 1 or 3 divided by square root of sine to power 3 to x minus 1 multiplied by sine to x minus 1 all to power 2 multiplied by cosine to x minus 1. This is the derivative of the given function. What is remaining will be only collinear algebra to simplify it. The main point in this part is how to find the derivative. Next step is just we can simplify it using collinear algebra.